The complexity of designing winning race cars and motorsports is often overlooked. One area of complexity is the massive amount of test data engineers must deal with in vehicle design. For example, during racing, our customer Jota Sport produces 7,500 data points per second coming from hundreds of sensors. The sampling rate of 50 Hz can go up to 1000 Hz on the test rig, which drastically increases the amount of data engineers have to work with, make sense of, and ultimately learn and adapt from. Sudden changes in tracks, racing rules, vehicle dynamic setups, weather conditions, and other highly stochastic processes such as the driver's behavior make this a nearly intractable modeling problem for every racing team. Innovative engineering teams are using reliable real-time predictions made by self-learning AI models to stay in the fast lane of this highly competitive field. Self-learning models can recognize patterns, learn from data, and become more intelligent over time. They need to be explainable, trustworthy, and reveal complex physical relationships under varying operating conditions and design parameters to improve vehicle performance, while at the same time help engineers shorten test and development time. The physical complexity aggravates predictability of unseen test scenarios, as these models need to learn from highly nonlinear relationships without generalizing, which refers to the model's ability to adapt properly to new, previously unseen data. Based on our work with the world's top engineering teams, automotive test engineers mainly face three key problems when it comes to track testing. They are unable to understand the performance of the full vehicle system due to its physical complexity. They waste time doing tests they do not necessarily need to do or that provide minimally useful insights. They are forced to use tools that are not tailored for engineering, data exploration, or engineering data types such as time series or tabular data. As a vehicle test or track engineer, you want to use the best technology available to learn from all the data you collect, understand your physical relationships, and ultimately increase your vehicle performance and reduce test times. Monolith provides a new AI solution enabling you to build accurate self-learning models to quickly understand and instantly predict the performance of your system, thus reducing the amount of testing so you can build and validate quality products much faster. Real-world track dynamics measurements of the overall car behavior as the driver performs different maneuvers around the track take a long time to record and are very difficult to analyze. Using Monolith, you can explore more operating conditions and design parameters and easily sort and visualize your test data to identify which parameters have the biggest influence on your racing or vehicle product team is after. Modeling the output of sensors to run at all times based on data previously collected can often be restricted by regulations, budget, or the ability to measure sensor inputs in the first place. However, the data collected can be used as an input for self-learning modeling and extract relevant information of your vehicle system in real time. Self-learning models can be trained on vehicle test data that capture the real physics to predict forces on the vehicle for new vehicle configurations or weather conditions under unseen test maneuvers, thus reducing the length and cost of test campaigns, ultimately reaching a desired vehicle setup much faster. All of that without explicitly modeling the physical system from scratch. This allows for a reduction of perform tests by up to 70% and care calibration times by 50% to characterize vehicle behavior. Test less, learn more, built by engineers for engineers.